Good day everyone. Welcome to our video presentation. In this video, we'll explain what recurrence relations are and how they help us build sequences step by step. What is recurrence relations? A recurrence relations is a mathematical expression that defines its term of a sequence based on the previous term. It is used to model process where the next state depends on prior state. So, a recurrence relation is a mathematical expression that defines its terms in a sequence, using one or more of the previous terms instead of giving an explicit formula for its term, like en equals 3n plus 2. It tells us how to calculate its term based on the ones that come before it. For example, one of the most famous recurrence relation is the Fibonacci sequence. Fn equals Fn minus 1 plus Fn equals 2. This means that to find the value of the net term, you add the two previous terms. If you know the values of F0 and F1, then you can compute every term after that using this formula. These are the key elements of recurrence relations. Number 1, base cases, initial terms that start the sequence. So, ang base cases, these are the initial terms of the sequence that are given directly. Without them, you would not be able to calculate the rest of the terms. Think of them as the starting point of the recurrence. So, using the Fibonacci example again, if O equals 0, if 1 equals 1. Base cases ensure the sequence is well defined, meaning we can compute any term as long as we go step by step from the base cases. Number 2, recurrence formula. A rule that conserves the current term to one or more previous term. So, a recurrence formula, this is the actual rule or equation that relates that current term to previous area. It defines the pattern or logic of how the sequence progresses. In Fibonacci, Fn equals Fn1 plus Fn2. There are many different types of recurrence relations. Some involve only one previous term, some involve multiple, and some even include function or constant.
So my topic for today is it's all about a simple addition pattern. So we're given sequence that follows our specific for pattern. So base case t0 equals 2. This means the first term when n equals 0 is 2. Then recurrence relation. So tn equals tn minus 1 plus 4. So this means that each term is 4 more than the previous term. So we can build the sequence step by step. So t0 equals 2, t1 equals t0 plus 4 equals 2 plus 4 equals 6. Then t2 equals t1 plus 4 equals 6 plus 4 equals 10. Then t3 equals t2 plus 4 equals 10 plus 4 equals 14. So, this is an arithmetic sequence with a common difference of 4 and a starting value of 2. So, problem 1. Find the value of t4. So, from the pattern t3 equals 14, so t4 equals t3 plus 4 equals 14 plus 4 equals 18. Then, what is the value of t6? So you can either build the terms one by one for use formula for arithmetic sequence. So tn equals t0 plus 4n, so t6 equals 2 plus 4 times 6 equals 2 plus 24 equals 26. Next is which term in the sequence is equal to 50. So use the formula again. So tn equals 2 plus 4n equals 50. 4n equals 48, and then n equals 12. So the 13th term, since Counting start from T0 is 50. So that's all. Thank you.
So, ang base case nato nganhi is T0 equals 1. T1 equals 3 times 1 equals 3. So, ang 1 gitimes na siya katulo. So, 3 ang answer. T2 equals 3 times 3. So, 3 sa ang imo nga di, 3 sa ban ibutang nga di. So, nodon dayon siya pagbutang. Kung ano answer mo nganhi, amo sab ang ibutang nga di. So, kay 3 sa, so 3 ang nga di. Equals 9. T3 equals 3. 9 sa ang imo nga di, so 9 sa bang nga di. 9 equals 27. T4 equals 3 times 27 equals 81. This is a recursive pattern. Permi nato gamiton ang previous result para makuha ang sunod. So, ini. So, sa paggamit ng constant multiplier o base case, we can generate a full sequence step by step. So, ingani da ang example. Thanks.
Why recurrence relation matters? In computer science, used to analyze recursive algorithms such as binary search and quick search. So, in computer science daw is makatabang sa ato mag-describe ng runtime, how to algorithm times complexity and change with input size. Napoy ko namin maka-breakdown sa problems into smaller instance, making it easier to understand the algorithm performance. So next is, in real life, helps model phenomena like population growth, compound interest, or infectious disease. So in real life daw, process where future state depends on past state, population growth, compound interest, infection, disease spread. Number 2 is pattern emerge. Understanding this pattern helps predict the future. So morning pag sabot daw sa pattern para ma-predict ang future. So next is in problem solving. Recurrence relations help to divide complex problems by breaking them into smaller, manageable sub-problems. So i-divide niya at conquer daw para mag-break down ang problema sa into smaller problems. So, napayan ay dynamic programming, solving problems, efficiently avoiding redundant calculation. So, by applying recurrence relations, we can analyze the algorithm performance and more real-world phenomena or solve complex problems